If this is your first time viewing my Flat Earthers debunking video, well, welcome dear viewer. This is part of a series where I look at one of their flyer and go through one section at a time. So far, we talked about their claim water is a natural level, airplane level flights, science says is stationary, and horizon is always eye level. Today, we look at their next claim. Mount Canigou in France is seen 175 miles away. According to the curvature formula of Earth 8 times miles square, the peak should be 3000 feet below the horizon. Infrared is very revealing. Followed by a picture of Mount Canigou. Next, a picture of Mount San Jacinto with label 123 miles. Mount Peak should be here for a curved Earth. With their 8 inches per mile squared equation, for 175 miles, we get 245,000 inches. Preserve sanity. That means over 281.6 km, we have a drop of 223 meter. According to Wikipedia, the Canigou is a mountain located in the Pyrenees of southern France and is located less than 50 kilometers from the sea and has an elevation of 2,784.66 meters. Oh no. Are they correct? Is it true? Can it really be? Well, are they correct with the given statement? Well, ignoring the sentence, infrared is very revealing, we'll come back to that later. Except that part, yes, they are completely correct. So what the heck is going on? Let's ask a different question. Why do things fall? Well, because of gravity. Now, if that answer sounded like a cop-out, then the explanation to this Canigou question would also sound like a cop-out. But unfortunately, it is what it is. So simple answer is refraction. Please don't go away, hear me out. To understand this, we don't really need to delve too much into scary looking equations. Rather, we will rely more on logic. That flyer did leave out some important facts though. The most important being, where was it taken from and what was the observer's elevation? As we move higher up, more and more of the Earth's horizon comes into view, which means if you're high enough, you'd be able to see any point as long it is not on the other side of the planet. Comparing that image with other images of that mountain, I'm almost sure it was taken from Metsil, that is around 250 km or 160 miles away. Again from Wikipedia, twice a year, in early February and at the end of October, with good weather, the Canigou can be seen at sunset from as far as Marseille, 250 kilometers away, by refraction of light. The phenomenon was observed in 1808 by Baron Franz Xaver von Zach from the Notre Dame de la Gradia Basilica in Marseille. Notice what it says, twice in year at sunset and good weather. What they really mean by good weather is clear sky with no haze. And if we believe that Wikipedia details, it means there shouldn't be any photographs taken from Marseille showing Mount Canigou that was not at sunset. The image used in the flyer is obviously at sunset. I do encourage you to do a search by yourself and see if you can find any such photograph. All I can say, my results turned out empty. This is something we can all verify by taking a trip to Marseille and check it for ourselves. So we are talking about phenomenon that is observed at particular times of the year at a particular time of the day. Now what else do we know that follows the pattern? Well, we have the Earth's rotation, i.e. day and night. We have tilt axis of the Earth and its orbit. Interesting. Let's ask a different question. On a flat Earth, would that mountain not be visible all time, during whole day and night, and throughout the year? I will try to explain it and will also try to keep it simple. First of all, what is refraction? Well, light while moving from one transparent medium to another would bend, and this is what we call refraction. The formula used to describe the relationship between the angles of the beam was first accurately described by the Persian scientist Ibn Sahal at the Baghdad court in 984 and is now known as Snell's law. Imagine a perpendicular line from the surface of these two medium, and that line is called normal line. And the higher the angle difference is between the normal and the light beam, the greater the refractive angle is. If the light happens to hit at 0 degree, then there is no refraction. Now, the density of our Earth's atmosphere is uneven. It decreases with increasing altitude. Light from celestial objects, including the sun, therefore refracts multiple times when it enters the atmosphere from space. Putting this all together, light rays that travel straight down do not bend, while rays that enter the Earth's atmosphere at a shallower angle get refracted and bends towards the normal, roughly following the direction of the Earth's curvature. Which means that celestial objects in the zenith position directly above you appears in the correct position, while objects closer to the horizon appears to be higher up in the sky than they actually are. This effect is especially more prominent for objects that appear close to the horizon, such as the rising and setting sun, because the light rays enter the Earth's atmosphere at a particularly shallow angle. Thanks to refraction, we may actually see the sun several minutes before it actually rises in the morning and after when it sets in the evening. Hogwash, you say. Can we see this by ourselves? Well, some examples of atmospheric refraction would be, if you're sitting around a campfire, the person opposite you would appear to shimmer. This is due to refraction passing through the hot air, which is also rapidly moving, and thus its optical density is continuously changing. So the person appears to shimmer. No campfire handy? No problem. This is a similar cause of stars to twinkle. In stars' case, the physical conditions of the atmosphere keeps changing and the apparent position of the star fluctuates, which gives rise to the twinkling effect. Whereas planets? Well, compared to stars, they are much closer to Earth. We can consider planets as a collection of large number of point-sized sources of light. The net variation in the amount of light reaching our eye from all the point sources will average out to be 0. Thus, on the whole, the brightness of a planet always remains the same and does not appear to twinkle. Atmospheric refraction is why sun appears bigger during sunset and sunrise, and also the reason why it appears flattened during those times but circular at noon. If you can accept the fact that is refraction, then the mountain scene makes sense. When you see the sun touching the horizon during sunset or sunrise, in actuality, the sun is really below the horizon or already at negative axis. That refraction allows us to view part of the sun that is blocked by the curve. That is the same way an object silhouette behaves. Imagine that spot where you are seeing the light coming from below the horizon. Any object blocking the light would create a silhouette that would follow the line. Thus, we would see part of the object that is over the curve as a result. But doesn't that mean it should apply to all silhouettes at horizon? Yes, indeed it does. It also means sunset and sunrise is when the refraction is strongest. It is present at other times as well. What are the requirements for a phenomena like Mount Canigou? Well, to start with, we need a long distance of unobstructed view. Next, we need some landmark at that distance which is not visible at normal condition. Finally, we need a certain time of the year to have part of that landmark to be visible. It is a really cool phenomena, and there aren't many places like that. The time of the year is important because, well, where the sunset during the year changes, stupid orbit. And in case of a mountain, you really want the sun to be behind the peak. When we see that Mount Canigou picture, we're seeing the very top of it in silhouette. And it's approximately 1/10 of the whole mountain height. Now imagine the sun was setting on a position that didn't catch that silhouette. First, satellite photo of our viewpoints. There we have long distance of unobstructed view. Now the following images are from suncalc.org. We are seeing sun's position that was on 1st of February 2020. Yellow line is sunrise and orange line is sunset. I have also marked Canigou over here. Next, the very same place, but where sunset would be in November 2020. Finally, the day of this video, 27th of August 2020. Because I used today, it has an additional line showing sunbeam for that day and time with a sun symbol at end. This perfect place gives us this beautiful scene. Amazing. But the Earth is still a spherical object. We can see Corsica from Monaco during sunrise. Once the sun rises further, it is no longer visible. Now Corsica is another such place. First search on internet for Corsica seen from Nice brings us the first result. A few days a year it is possible to see the Corsica from the Côte d'Azur, Nice, Eze, Monaco, Menton, Grasse, Gordon, Vence, about 180 kilometers. It doesn't say which days of year. I know what that time is by using SunCalc. Let's leave that as a task for you, should you choose to accept it. Now, can we calculate this refraction? Well, we often use a formula. The calculation is based on a formula that was given by Gigi Bennett of the University of New South Wales. This empirical formula also has pressure and temperature correction. This calculation is approximate and is accurate to 0.07 arc-minute. But obviously, these equations cannot take other interferences or variables into account. What I mean by that is, well, suppose after you have your camera set up, you light a campfire in front of it. We calculated atmospheric refraction, but then we threw in a new variable. But there is no point of doing that calculation with our limited data. We need the position where the photo was taken, and thus find out the exact distance and elevation. Only with all those values, we can figure out an estimated refraction value under certain condition. Next statement, infrared is very revealing, exclamation mark. Well, technically it is true. I find infrared revealing all the time. You're seeing two of my torches. One on the left is UV and the one in right is infrared. I play with them all the time. But in all seriousness, that word has different meaning based on context. When we talk about infrared photography, we generally mean a filter that blocks out almost all visible light, making it possible to capture what we call infrared images. In landscape photography, foliages are rendered bright white and blue skies are captured as almost jet black. The flyer shows a photograph that is taken from a video by J. Tolan Media One. On that video with the description, Mount San Jacinto from 123 miles in high-resolution infrared from Malibu on 1st of January 2019 on a very clear day. Before continuing, can the flat earthers please understand something? Visible light spectrum is a section of the electromagnetic spectrum that the human eye can detect, and the part we cannot see with naked eyes are still being refracted. Yes, non-visible light also experiences refraction, just saying. On the flyer, I think they're making the wrong argument compared to what J. Tolan Media One does. Even if we go with their 123 miles, with a viewer height of 0 feet, the hidden value should be 10,080 feet, whereas elevation of San Jacinto is 10,833 feet, so around 6.95% of that mountain would be visible. On one of the comments, Zetolan gave us a latitude and longitude of where he thinks he took his IR shots from. That is 34.032204 degree north, 118.702984 degree west. Plugging that into Google Earth gives us a source elevation of 47 meter. Next, if I search for San Jacinto Mountain, I get a coordinate, but that coordinate gives me an elevation of 3264 meter. So obviously that's not the peak, as it is 38 meter lower than peak. But looking at Google Earth, it looks very close to the peak. The distance between Zetolan and this coordinate is 188.3 km or 117 miles, and not 123 miles. But to be fair, the flyer might just be using a different image than the one Zetolan is mentioning here. But using that coordinate tells us 3,921 feet of the mountain would be visible. For those keeping count, that's 36% of that mountain. As my understanding, Zetolan makes the argument that first, if the curvature was real, then the hills in foreground would obscure the larger mountain that is far away. You can easily understand this by bringing your finger closer to the eye and notice how it's obscuring objects much larger. Then his next argument is that San Jacinto isn't as tall as we are being told. Is there any way to disprove those claims? Glad you asked. Some YouTubers did a much more detailed analysis of these claims, and links would be in description. I will go through a quick debunking. Given a path, starting from Zetolan's origin point all the way to the peak of San Jacinto, Google Earth can give us an elevation profile. So this is all the objects in our line of sight with their elevation. Now, given our initial view height and the peak height, we calculate how high an object needs to be to obscure the peak on around Earth. Finally, if we plot the values and overlay on top of elevation profile, we see that there are no hills in that line of sight high enough to obscure the mountain. Ruhiv did a video showing this in more details and also proving why Zetolan is wrong about the mountain height. We'll ignore that as it has nothing to do with flat Earth. Dr. Bob also did an amazing video where he overlaid the mountain image from Google Earth on Zetolan's infrared image to show how much of the mountain was hidden from view. And it is exactly what our curvature calculation predicted. Again, link in description. So in my opinion, infrared in a way makes it heavier in contrast. I would argue that this image actually proves the Earth's curvature, as it completely fits with our globe model. At one point in history, astronomers noticed discrepancy in Uranus' observed position in contrast to its predicted position. The planet was not quite where it was mathematically predicted to be. The formula that works with every single other observed planet so far didn't match up. Did we immediately throw away the equation? No. Many popular notions of the time attempted to explain this deviation, starting from perhaps Newton's law of universal gravitation ceased to work or worked differently at such great distances from our Sun. The problem with the orbit of Uranus caused astronomers to begin speaking of another possible planet beyond it. The French astronomer Urbain Le Verrier began using mathematics to try to locate mystery planet's position in June 1845. On September 23, 1846, Galilei used Le Verrier's calculation to find Neptune only 1% of Le Verrier's predicted position. My point is, At times, there might be other explanations rather than the earth cannot be curved. That curvature works, and for some cases, other explainable causes like refraction causes Mount Scanagio to appear. Taking away globe model, the other models has no explanation of any of it. Well, that's all for this video. If you have managed to watch it so far, thank you so very much. I hope you enjoyed it and would give the video a like and maybe a comment to fit the YouTube algorithm. If you could also subscribe for similar contents, that would definitely help my small channel grow and would be thoroughly appreciated. Have a safe day. Signing off.
We are one people, and we, like you, we are one tribe.